Today, hi everyone. My name is Daniel. I am a MD PhD. In my daytime, I see eye patients. I do eye surgeries. I'm a retina surgeon. On my nighttime, I do computer science, AI, and in ophthalmology and in health. So I'm currently a Duke-NUS faculty. I'm also a visiting faculty in Stanford. And in fact, 2 weeks ago, we had a one-week Stanford AI Health Week. We talked a lot about what we just spoke about today, AI safety, how do you use AI in a safe and responsible way. And in health, as you know, the moment that your mom or your dad or your son or your daughter falls sick, you come to the hospital, you see a doctors, and when the doctors start telling you that I'm using AI too to diagnose your kids, to diagnose your parents, you will start getting a bit tachycardic. In a layman's term, your heart will start to race. So I think for the next 10, 15 minutes, I'm going to share with you some of the journey that I personally have undergone for the last 10 to 15 years, all the way until now, and see where we are doing and where we are heading. So I think this is some of my financial disclosure. Right now, I don't actually need to pitch this to everyone sitting here, the reason why you're here, you're interested in AI. But I just wanted to actually highlight that we have actually gone through different iterations. So SuperAI, this is a conference, but AI is a 70-year-old technology. So it started at Alan Turing's time in World War II, with him cracking the Enigma code, all the way to Chat 3.5, started 2.5 to 3 years ago, that have actually change how we think and how we live. I wanted just to remind everyone, in science, in technology, one of the greatest awards that a person or a scientist can get is called the Nobel Prize. And I'm pretty sure 100% of people know what Nobel Prize is. Last year in 2024, we have 3 computer scientists who won the Nobel Prize award. 2 in the physiology space and 1 in the chemistry space. And we know Jensen said that, right? Right now, no matter whether you are currently building a hardware company, a pharmaceutical company, a drug device company, you will need the second brain, which is AI, which is software. So you need 2 factories to work together to make your device, to make your drugs, to make your hospital, to make your agriculture, to make your vehicle smarter. So this is what we know. COVID time is just, it has just passed about 4 or 5 years ago. And this is one of the time that has turbocharged the adoption of AI and tele-ophthalmology as a new part of the care delivery in health. This is an article that we published in Nature Medicine back then. And Victor Zhao is currently the president of National Academy of Medicine in the United States. So we co-authored this paper just 2 months after the outbreak of COVID. So this article was actually picked up by the US CDC to actually educate the world how we could actually adopt AI and digital technology to provide care when the whole country or worldwide healthcare system is experiencing a lockdown. So that was just 4 to 5 years ago. So if you look at the chart here, for the last 3 to 5 years is 2020 to 2025. So this is a chart that has just stopped at 2020. That is a pre-gen AI era, and we already have seen many AI interests has sparked off tremendously in the healthcare space on different AI, the tasks, the different AI domains, and different medical specialties. If I were to summarize what AI has done in health for the last 15 to 20 years, you can start from the top. So it started as a numbers analysis. It goes on to a picture-based, a computer vision era. And right now, for the last 2.5 years, it's a text, numbers, and as well as image and videos and speech. And that's what we call multi-modal. Irrespective of what technological changes that we are seeing on the top, we always need to make sure that the AI technology, the moment that you use it on your hand to deliver care, when a patient is sitting right next to you, you gotta use it in a safe and responsible way. No different from the moment that you put a pair of your hand on the steering wheel, you gotta drive the car in a safe and responsible way. We do not need you to be a car engineer to know how the car is being made. But the moment that you drive a car on the road, you need to be safe and you need to be responsible. So this is the era where I started. So Fei is my Stanford colleague. She put together an ImageNet, a database called the ImageNet. That has actually changed how we think about training AI system. So I started with the pixel-based convolutional neural net, the era where we actually not training, we have a VGG net after the AlexNet. Back then was a untrained CNN era. The moment that the ImageNet comes out, then we started pre-training CNN with the ImageNet database, including the medical imaging analysis. So if you look at transformer architecture, it was described by the Google researcher in 2017. Attention is all you need. So this paper has really changed how we actually think about the back-end architecture about convolutional neural nets all the way to the transformer architecture. And you look at the version 1, 2, 3, 4, and many others, all up until the mixture experts, multi-agent system, the DeepSeek, right, Manus, Quen. These are all the newest, latest AI optimization techniques that we have actually seen in the generative AI space. And AI can never work alone. So the moment that you come to the hospital setting, you come to the healthcare setting, you gotta actually remember that AI has to always talk to many different stuff. So that includes the AR technology, the VR technology, your HIM system, your EHR system, your variables. There's many other things that you actually can see on the slides. If you were to actually build an AI technology and use it in the healthcare and commercialize it and scale it and get your startup company to get listed in NASDAQ and New York Stock Exchange, this would be the whole entire journey you have to undergo, right? And sadly speaking, we always see 90% of the AI ideas, AI papers stop at the ideation and stop at the publication stage. The moment that you ask any AI developers or AI designers in health and asking them, hey, is anyone using your solutions in the clinic? Less than 5% say yes. And 3 to 5 years later, for those who say yes, is your solution is still being used in the clinic? Less than 1% will say yes. So this is what we call the valley of death in health, right? So if you were to actually do the first 90%, low-hanging fruit well, if you were to submit your paper, high publications, right? A lot of yourself, AI developers, some of your applications may apply to the healthcare settings. And if you work with the clinician, this is the number one thing they care about. Is my paper is going to be submitted to Science, to Nature, to, so those are the things that they care about. So if you were to do that, this is the top 5 things you have to understand. First, what is the question? Where is your data going to come from? And what is the brain that you're going to select to actually use your data to build the algorithms? And the back-end architecture, how are you going to actually create the operating system? And of course, what is the primary endpoint? Because if you were to submit this to the US FDA, to the EMA, to the Chinese FDA, to Singapore HSA, you all have to know this. And of course, when the moment that your AI solution is being approved, the next question is, how do you use it, right? Am I going to deploy in the cloud? Am I going to use it in a laptop? What is the data ecosystem? How is the data going to flow to your AI algorithms? And how are you going to protect the data that comes into your AI system? So all these little things is all critical for you to continue to provide your solutions in the healthcare settings. And of course, the last but not least, the money. We hate to talk about money, but who's going to pay? What is the reimbursement methodology, the strategy for your solutions to continue on to actually be paid for and to be used? So I just wanted to highlight a few things, right? In AI, deployment is either you use AI in a 100% automated way or you keep the human in the loop. So it's as simple as that. And in the US FDA, the route, if you were to submit any AI as a medical device route, is either refer, not refer. A lot of them has gone through the US 510K route. And if you're more high risk is treat or not treat, that would actually be considered either a Class C or even a high risk device. Regulatory approval from different countries are different, so you always have to think about that right at the outset, so that you don't actually need to revamp your AI technology that you have built, tirelessly for the last 3 to 5 years again. What is a business model? Am I actually look at B2B? Am I B2C? Am I B2B2C? So those are the different business models that we've actually seen. Health economic analysis is very important because that actually helps you to actually look at, if I were to use AI in the real-world settings, what is my return on investment? These are the 2 papers that we actually published in the Lancet series journals. This is one of the solutions that we're currently using in the AI National DR Screening Program, where we published a paper in 2017 in JAMA. So back then, we used a pre-trained VGG net, and we found that using the health economic analysis that guides us how to use it in the real-world settings. So semi-automated way, based on what we've actually done, it shows us actually most cost-effective, the combination of human and AI intelligence. So this is currently, we use 100% AI to screen. For those that AI is deemed abnormal, then you will go through the human for a second read. I always like to ask this, does anyone not know what this is? Right? So, and when I actually show this icon, to my surprise, more than 50% of people still get it wrong. So, anyone? Please shout it out. Meta AI, yes. Wow, one of the first time. What about this? DeepSeek, yes, I like it. Yeah, so this is a paper that we published 1.5 years ago. Currently, it's been cited more than 100 times per month. So that was just 4 months after Chat 3.5 was released, if you can look at the submission date. So we know Gen AI applications in health is mostly broadly divided to the text, medical imaging, and speech, ambient AI. And this is the 2 articles that we then published that say, how do we use it in a safe and responsible way? And we look at the different AI training techniques. You go from the prompt all the way to the pre-training. You use like the A140 gig, or you can use a laptop-based, the GPU power, all the way to B200 Blackwell, the high-end compute power. But I wanted to draw your attention to the bottommost. I started in a supervised label pixel-based CNN era. So right now, you can see the evolution of the AI training techniques is going from supervised to weakly supervised to unsupervised to supervised fine-tuning to supervised to reinforcement learning. So this is where we have seen the whole entire journey of the Gen AI space. Of course, this is just a snapshot on the closed source versus the open source on the tiny, small, intermediate, and the mega models. And I just wanted to share, this is something that in SingHealth and Duke-NUS we have just spun off startup to look at the agentic, sovereign, small language model, the resource-efficient AI models to help the healthcare administrator to calculate the clinical audits. So you can look, the tasks that require more than 500 hours previously, the time when we actually use Enigma, the small language model, to automate a lot of the tasks for us, it brings right down to the 7 hours. It's more than 90% reduction in workload. So this is one of the media release that we have had in a recent ATX summit with Roche and ST Engineering. And what is Enigma? Enigma is World War II, the one that Alan Turing has cracked to win the war. So right now, we are leveraging a mixture of experts, small language models that do not need internet connection. As you know, in healthcare, similar to many other industries, we have to handle many sensitive data. So this is some of the things that we are currently doing that can connect and can be connected to the different databases and the different the file format. So this is the different stuff that currently we have already done on the pharmaceutical, the industry, the insurance, the finance, and the human resource operation as well. So I think this is my last slide. So data privacy, rights of use, the data provenance, the IP contamination is always an issue. Gen AI is very broad, so we do need a lot of the governing framework to actually govern that. So this is the Smart Nation. This is our PM has actually announced the 2.0 Smart Nation strategy. This is where we actually are advocating a safe and responsible use in the healthcare settings. This is our labs that we've done quite a few, the AI, the healthcare-related application for the last 10 years. And this is so far what we've got. We invite, the industry players, the startups, the MNCs to come to SingHealth and Duke-NUS. Please reach out. This is some of our pipelines of our AI talents in our healthcare system. And this is the interns that come from MIT, Cambridge, and Oxford to join our labs. And this is also some of the clinician entrepreneurs that we have incubated, and now they have gone on to the industry. And this is the last, I'm not sure whether, This is the last 30 seconds demo that I want to share with the world. In the past, we actually need 3 months to 4 months to write a systematic review. Right now, by feeding this into Enigma, we can do it within less than 60 seconds times with 3,000 words of a very well-researched literature and a very well-cited references from the different evidence, as you can see from the screen. And once this is clicked, and you see the whole entire table of contents, all the way from backgrounds to the searching strategy, all the way to the conclusion and the references. So with this, I thank you.